Welcome to the PrairieLand Advantage video series. This topic is about all STS combines and how the crop flows through those combines, and this particular video is about the cleaning system. Let's get started by looking at our index here, which is going to help you find where you need to listen in this video if you have something specific you're looking for, instead of listening to the whole thing. I'm Drew Lowry. I'm with you today, and we get to talk about the crop flowing through the cleaning system. Now, hopefully you've listened to our other videos, and we've explained the threshing area and the separating area, and how the material other than grain exits the discharge beater into the residue system. But what we're talking about now is the crop I'm pointing out here is that crop coming out of the separator area and the discharge beater grate falls into the return pan. Crop coming out of the front two concaves goes onto the conveyor auger. Crop coming out of the third concave falls directly onto the fixed front chaffer. So the fixed front chaffer is a very important part of the John Deere STS cleaning system. Why is that? Well, what that does is it starts our cleaning process. So it is called a fixed front chaffer because the louvers in it are welded in place, so they cannot be adjusted, hence the name. So what we do is we divert a high speed volume of air into the fixed front chaffer, and all that grain and material other than grain that is entering the fixed front chaffer is hit by that blast of air, and we try to get many of the pieces of material other than grain elevated and yet let lots of grain rain down through. Now, let's say a medium-sized piece of MOG falls through those fixed louvers. The finger section is going to catch that and divert it to the adjustable chaffer. Now, the chaffer is adjusted from the cab or from the ground, and we then want you to set that appropriate to the crop. Now, the grain, once it fits the chaffer, is given access to the sieve, and all grain on the later machines goes through the sieve because the sieve is what makes sure the grain tank sample is clean. Now, grain that fits through the chaffer but won't fit through the sieve is called unthreshed or small MOG. What that does is it moves rearward to the back of the sieve, falls into the return system for reprocessing. So hopefully this was a good overview of the whole system. Let's look at the actual components. I think it'll make more sense. Let's look now at that fixed front chaffer shown in yellow on this actual picture. That fixed front chaffer is the recipient of grain from the front two concaves through the conveyor augers. The third concave falls directly on it and off of the return pan coming from the rear of the machine. So as you watch a video in just a second, you can see that this return pan is going to get grain from the discharge beater's grate, shake it until it gets forward and falls on the fixed front chaffer. Let's watch this video explaining what I just described.
The grain pan, which now features multiple grain diverters. These new diverters allow grain and trash to flow evenly onto the full width of the extended front chaffer, while dramatically reducing overloading of this critical cleaning area.
So did you notice in the video that the fixed front chaffer is fixed as far as its adjustment, but was moving with the shoe frame itself? So this is a busy area, and the crop coming from the rear of the machine moves in and accesses the fixed front chaffer as we get to the center of the machine. Now let's talk about the conveyor augers. The conveyor augers receive the grain from the front two concaves, and much of the separation has to be done by the threshing section or in the concave area. So that's why I've colored this red. The third concave is right above the fixed front chaffer, and so that falls into the actual fixed front chaffer itself. Now, one of the things that's interesting when you do our power shutdowns is make sure that you look in at these conveying augers. You'll see the material other than grain kind of bubbling to the top and the grain on the bottom. And so we're actually starting our cleaning process all the way at the front of the machine here. This video is hopefully going to help animate the things we just described. All right, that video mentioned something that I need to review, and that is we prefer crop on crop threshing. So, one of the things we understand is that to be gentle to the crop, if it's rubbing itself, it's going to be about as gentle as it can be. Now, you can notice that the conveying augers are dumping that crop right here on the fixed front chaffer, but you did see that moving back and forth with the shoe frame like I described it in the previous section. Now let's talk about that fixed front chaffer. That fixed front chaffer is got welded vanes that are non-adjustable, and it gets grain from three different directions. So that as the fan blast, and we'll talk about that later, comes up through these fixed vanes, what that does is allow the grain to move down and part of the mog to move rearward onto the chaffer, which is right there in green. Next, we need to talk about the feature that comes on Class 8 and 9 S Series combines that's called the front chaffer extension. Well, this fixed front chaffer works so good, we added an extension when we went to the larger horsepower machines. So the fixed front chaffer is here. The front chaffer extension is literally bolted to it right behind. Now, because this is going to need a bigger amount of air because it is a bigger surface area, we have a redesigned windboard. And that redesigned windboard is going to divert more air up here that's going to allow us to fulfill the needs of the fixed front chaffer as well as the front chaffer extension. So one of the things we need to understand is to grab that air as we need it to do its lifting job and cleaning job are these diverter vanes. These diverter vanes are on the bottom of the fixed front chaffer and aren't needed on the front chaffer. So that is the difference between the two. Moving on back to the chaffer, this is where a high percentage of the cleaning is done. Please comprehend that the first job of the chaffer is to keep grain in the combine. Studies have shown that if the grain is on the ground, we're not going to get it clean. So that is a bad joke. But the bottom line here is I want you to understand that we need the right chaffer for our different crops. So we offer at least two different chaffers, the most common of which is the general purpose for small grains. Now you can see the teeth of this chaffer are 20 millimeters long, shown by the blue line there. And that is ideal for the smaller grains like wheat, things like that. Larger kernels need a longer tooth, so the 30 millimeter shown by the green line teeth are the deep tooth chaffer. So small grain, short teeth, large grain, large teeth. So that's how I remember the difference between the two. And we actually have a third chaffer we'll talk about in the adjustments section. All right, so the crop falls through that chaffer. And remember, the purpose of the chaffer is to keep grain in the machine. So that means we're going to have to let some material other than grain through the chaffer into the sieve. So shown here on this picture with the chaffer removed is the sieve. And please understand that the primary job of the sieve is to clean the grain before it goes to the grain tank and to divert the unthreshed crop into the return system. So that is why the sieve is set significantly tighter than the chaffer, because the chaffer's job is just keep it in the combine. The sieve job is to keep the grain tank sample clean. Let's look at this from the left side of the machine. The crop that fits through the chaffer but won't fit through the sieve because it is part of an unthreshed situation will move itself to the rear of the sieve, fall into the return system crop flow, and access the return system cross auger. So that's how we're going to process this grain and recover that grain that's in that unthreshed head or cob. So let's talk about the system that does that. If you have a 50, 60, or 70 series combine, your elevator looks like this. It's a 45-degree slant up to the right. And if you have a class 5 through 7 S series combine, it's going to look like this too. So what's going on here? Well, that auger I showed you a second ago is coming out here where I'm pointing. There's a paddle elevator that raises it up, drops it into a second cross auger, but you need to understand what that cross auger is doing. It is delivering it to the center of the center concave on this group of machines. So what that means is I'm going to go back and join the crop that's coming in for the first time and be processed. So the center of the center concave is where the return system dumps on the class 5 through 7 and the 50, 60, and 70 machines. Now, on the S series combines class 8 and 9 machines, we have a autonomous return processing system. So what we have is, of course, our cross auger here that compiles the crop. We have a vertical paddle chain that delivers the return crop to a 10-wing auxiliary threshing cylinder. Now, this cylinder can be set in small or large grain settings, and so effectively we are processing the things that won't fit through the sieve separately on these larger machines than we do on the smaller units. So that's how this works, is we then process it, we rub it. This is just a Raspar style cylinder, and then we return it, but to a different place. And we return it to the shake pan because we don't need to return it to the threshing area because this is our auxiliary threshing unit. Now let's note that we want this crop to be spread evenly around the shake pan as shown here by these yellow arrows. So as we watch this animation, let's see if we can spot all the tailings adjustments as well as tailing processes that we can see on these class 8 and 9 machines. All right, so you saw a lot of going on there. Let's review. What we have is our crop that won't fit through the sieve, falling off the back of the sieve and coming to our tailings collection auger there. We raise this up to the right side of the machine and run it through our 10-wing auxiliary threshing cylinder, and it is set for either large or small grains. It then falls out of that cylinder into our redistribution auger, but different than the smaller class combines, we send it to, instead of the threshing area, we send it to the actual return pan. Now let's look at the metering tube that is returning that to that return pan. Please note, now we're looking from the left-hand side of the machine now, that the openings on the right-hand side of the machine are small, working up to larger openings, and the purpose for that is to spread the returning grain evenly across that shake pan. This works really well and helps the capacity of our high horsepower combines. Let's go back to our sieve discussion. And remember that our primary purpose of the sieve is to clean the crop going into the grain tank. So the pieces of material that we call material other than grain won't go through the sieve if you have it set right, but the grain will go through the sieve. So let's look at the sieve receiving area from the left. So I've drawn that in yellow so that anything going through the sieve, and that's right here, is going to slide forward to the clean grain cross auger and be elevated into the grain tank. So that's why chaffer and sieve adjustments are so essential to do it correctly so that we can get a good grain tank sample. Now let's talk about the third component of our cleaning system that we've just briefly touched, and that is airflow. That is a huge part of our cleaning system. So we need to understand that air adjustments are crucial to our chaffer and sieve adjustments too. Now shown here is our Dynaflow 1 cleaning fan found in the 50 series. You can see we have a 700 RPM range of that 17-inch diameter fan. So we're talking a serious volume of air. Now that air volume is split 80% in the access to the chaffer and sieve through the lower outlet, 20% to the fixed front chaffer here through the upper outlet. So what we're doing is we're dividing the volume of air and speed of air to the different responsibilities that we've already been talking about. Now, if you look at this from a overall perspective, 20% of the air on class 5 through 7 machines goes to the fixed front chaffer at a high rate of speed. 80% of the air, which is a large volume of air, goes to the chaffer and sieve at a lower velocity. And so that's how we clean our crop to be a good sample. Now, when we put the fixed chaffer extension in, we need more air, a higher percentage of the air. So we have a redesigned windboard that is going to give us another 10% of the air volume and at that high velocity up to this fixed front chaffer. So please understand that there are a lot of things to adjust in the cleaning system, but one of the things that you need to comprehend is if you start with operator's manual recommendations, you'll probably be in a good starting place. At PrairieLand Partners, we believe that we are delivering you the right solutions with these John Deere combines.